Introduction to Paper 41. The second slide of this presentation shows a view of the master universe that portrays the universe as many Urantian artists have done. Note that Urantia is shown in the center of a spiral galaxy, probably our Milky Way galaxy. The implication is that the Milky Way galaxy is Urantia. The central universe and a portion of the first outer space level is shown as well. There is some evidence in the Urantia book to support this conceptual picture of the master universe. But how does this picture correspond to what our astronomers and astronomy satellites image as they look out on the universe? The second slide shows what our galaxy might look like from some distance away. The galaxy is actually M31, the Andromeda galaxy, our nearest neighboring galaxy, which is a bit larger than our galaxy, but a spiraled galaxy like the Milky Way. But there is some evidence in the Urantia book that Urantia may be more than a single galaxy. The fourth slide shows what Urantia would look like if it were composed of a small group of galaxies. Is a small group of galaxies large enough to be Urantia? The fifth slide shows how Urantia would appear at a distance if it were a large group of galaxies. This group is a deep field view that was imaged by the Hubble Space Telescope. If the Milky Way galaxy were Urantia, it would be composed of 10 major sectors, each of which would be composed of 100 minor sectors. The authors indicate that we can see 8 of the major sectors. Do we see these divisions in our galaxy? The sixth slide shows a cross-section of the major arms of our galaxy. Our astronomers have worked for many decades to construct a picture of our galaxy. This is difficult to do from inside the galaxy, but they have been able to piece together a reasonably close picture. Note that our galaxy looks pretty much like other spiral galaxies. It is not composed of 10 sectors, each rotating around its own center and all rotating around a common center, but rather 2 major arms and several minor arms rotating around a common center. Slide 7 is an artist's conception of our galaxy showing the arms and our location within the Orion arm. Note that the galaxy itself could fit the description of either a major or minor sector, since it is an identifiable entity and rotates around a common center. Slide 8 shows the local group, which consists of our galaxy, the Andromeda galaxy, and a number of satellite galaxies. This group doesn't look much like Urantia as described in the Urantia book, but according to astronomers, the 2 galaxies do seem to rotate about a common center. Because of this, some have proposed that the local group might be Urantia. Slide 9 shows the Virgo supercluster, which contains over 1,000 galaxies, including our local group of galaxies. And it is this supercluster that John Coslin proposes in his slideshow could be a superuniverse composed of 10 major sectors, each of which is 100 minor sectors. Slide 10 shows a grouping of superclusters. John feels that 7 of these could be the 7 superuniverses. Slide 11 shows what the universe looks like at a scale of billions of light years. It's hard to see structures in this slide that resemble the artist's concept of the master universe shown on the second slide. By the way, John Coslin's slideshow is one of the suggested materials for this course. Slide 12 shows the various constellations seen in the night sky. The elongated gray portion is this cross-section of the densest part of our galaxy. The bulge seen in the corner of the gray area is the midsection of the galaxy. Note that when you look toward Sagittarius, you're looking toward the center of our galaxy. Now let's consider the last statement in the introduction section of paper 41. Such is the constitution of the local star cloud of Nebulon, which today swings in an increasingly settled orbit around the Sagittarius center of that minor sector of Urantia to which our local creation belongs. Now you might think this means that the center of rotation is located among the stars that constitute the Sagittarius constellation, but this is probably not the case. Many astronomical objects are named after the constellation of which they appear in, even though the objects are quite distant. For instance, the constellation of Andromeda is located in our galaxy at 44 light-year distance, but the Andromeda galaxy is about 2.4 million light-years distant. Slide 13 shows a combined radio and an infrared picture of the center of the Milky Way galaxy. The arrow points to the center about which our galaxy rotates. This object is a black hole with a mass of about 4 million suns. It is known as Sagittarius A star. Paper 15 has some statements about our minor sector similar to those in paper 41. The authors refer to our minor sector as both Sagittarius and Insa in paper 15. You might think this settles the matter in favor of a larger Orvonton, but if you read my paper, A Tale of Two Orvontons, in the list of supplemental materials, you know it isn't settled. Paper 15, Section 3 uses terms to discuss Orvonton that make it seem that our superuniverse consists of the Milky Way galaxy, or perhaps our galaxy as only the nucleus of Orvonton. But they also say that we are located in one of the arms of the distorted spiral. In fact, this is none other than the Orion arm of our galaxy, shown in slides 6 and 7. Paper 15, Section 4 speaks of two stupendous stellar coils that emanate from the center of our minor sector. In fact, astronomers now conclude that our galaxy has two major arms. If the authors did indeed present two different pictures of Orvonton, why did they do that? There are many numbers given in paper 15 about the master universe. One number of interest is the number of blazing suns in Orvonton. According to the authors, there are 10 trillion such suns in Orvonton. According to astronomers, there are about 200 to 400 billion stars in the Milky Way galaxy. As you can see from slide 14, 10 trillion is 50 times larger than 200 billion, and 25 times larger than 400 billion. So unless our astronomers have grossly underestimated the number of stars in our galaxy, it would take 25 or 50 Milky Way galaxies to equal one Orvonton. This reinforces the idea that our Orvonton may be much larger than our galaxy. Section 1. The authors begin this section by making reference to spiral and other nebulae. The authors use the term nebulae to refer to both large collections of gas and spiral galaxies. This is the common use of the term in the early part of last century. Slide 15 shows a well-known nebula, the Eagle Nebula. This is the sort of astronomical object to which modern astronomers apply the term. The authors of the Urantia book state that the galaxies, spiral nebulae, are started by the Paradise Force organizers. This process is described in paper 15, section 5. Slide 16 illustrates the flow of energy once it has reached our local universe. The energy is progressively transformed to lower forms as it travels from Paradise down finally to the inhabited planets. This is somewhat similar to the way that electrical power is distributed within our country, as shown in slide 17. But the transformation in this case is from a higher voltage to a lower voltage. The authors say in another paper that the energy lanes are used to carry communications as well as energy. In fact, power companies also send communications over the power lines as well as power. The power centers and physical controllers who control and direct the energy flow are described in paper 29. In this section of paper 41, the authors refer to the way that architectural worlds are heated and lighted. This process is described in paper 46, section 1. The reflective layer in the atmosphere of our planet mentioned in paper 46 is the ozone layer, from which radio signals can bounce from one place on the globe to another, as shown in slide 18. The heating mechanism described is like our baseboard electric heaters. As the electrical current travels through the wires in the heater, heat is generated. At the end of this section, the authors state that the Satania Power Center occupies a dark island. There has been conjecture for a long while within the Urantia community that these dark islands might be what our astronomers call black holes. Our astronomers call them black holes because nothing, not even light, can escape from the black hole once the object comes closer than a critical distance to the black hole. Slide 19 shows an artist's conception of how a black hole might appear if we were close by. Not all black holes emit the jets of material from the poles. The black hole at the center of the Milky Way galaxy does have these jets, but they can't be seen in slide 13. Slide 20 shows another artist's traditional view of the master universe. Slide 21 shows the distribution of superclusters around the Virgo supercluster, of which the local group is a member. Are these the 7 superuniverses? Could be. This concludes the presentation covering the introduction and section 1 of paper 41.